moderator of this panel session. I'm Koyama from Fujitsu. Nice to see you all. Today, we are going to have this panel discussion for the industrial usage of quantum computing. In the area of application development, the companies who are doing the joint research and development with us are here as the panelists. And we are going to talk about the latest situation of application development of quantum computing. And we are going to hear from panelists. So I'd like to introduce the panelists. So from your left-hand side, Fujifilm, Mr. Okuno. Nice to see you all. And from Mizuho, Daiichi Financial Technology, Mr. Takeda. I'm Takeda. And next to him, Mitsubishi Chemical, Mr. Ko. I'm Ko. Nice to meet you all. And on the right-hand side, from Head of Quantum Research and of Fujitsu, Mr. Sato. I'm here again on the stage. And it is time when you feel sleepy after lunch, so we'll try our best not to bore you. And as a Fujitsu personnel, I'm Koyama, who do the research and development with you, and I'm going to act as moderator. And as in the forum of formal presentation, we may not be able to get the information about the daily activities, daily thinking. So we are going to ask about that. So I would like to ask each panelist to make a few words for greeting. And thank you very much for attending this panel discussion. And I think I have discussed with you online, but not face-to-face. So this feels very fresh. I'm not so knowledgeable about this proceeding of panel discussion. I may be irrelevant, but as I mentioned in my presentation, application is very important. That's the exit of the technology. And we can provide that to the customers and get the return from the customer. We started the joint research and development 2 or 3 years ago. And usually, quantum simulator, quantum computing, we have that technology. So usually, we have the technology and ask for the joint research. But 2 or 3 years ago, we didn't have that technology. But still, we asked for the cooperation to the joint research, and they accepted that. I really appreciate your mindset, your willingness to work with us. And for the future business, I think you are aware of the importance of the quantum computing, and I really appreciate your participation in this joint research. And we have accumulated good know-how in the past 3 years. I hope we can share that to the audience today. Okay, we'd like to start the self-introduction. Me? Yes. What you're actually tackling on your work? Yes, self-introduction, please. Yes, I'm Okuno from Fujifilm. Within Fujifilm, there's an organization called the Analysis Technology Center. And we are handling various materials and devices. We produce them, and our organization analyzes that. And we have a simulation team, and I'm a group leader of that simulation team. And in terms of the joint research and development with Fujitsu, should I talk about that? Yes. With Fujitsu, it's a relationship of vendor and the potential user for quantum computing. That's the relationship. So we do the computation of materials. So we are users. From the user's perspective, the development is very important for us, and that's the basis of this joint research with Fujitsu. Okay, next, Mr. Takeda, please. Yes, I am Takeda, and I am from Mizuho First Financial Technology. That is a long name of a company, and we call it Mizuho FD. And background? Solution technology, and I got a PhD, and then joined this company, quants and the actuarial analysis of financial institution is my work. And after joining this financial institute, I actually do the consulting for portfolio for institutional investors, or design the pension, or the making the model of share stock selection. And in the year 2019, I participated in the quantum computing project, and currently I'm engaged in quantitative credit risk model development, and I've been doing actually engineering work. And basis of computation becomes advanced, and with that, the basics of actuarial computation becomes also complex. And I took part in this quantum computing project because of that, and then we are using the technology and the devices from Fujitsu. Thank you for this opportunity. Mr. Ko, please. I'm from Mitsubishi Chemical. My name is Kochi. My expertise is in computational science, and in the year 2007, I joined Mitsubishi Chemical Corporation. And computational science is the technology platform that we have in our company. I joined that. And computational science platform is actually computational technology to do the material development computation. And I'm a team leader of quantum computing. And for the material development industry, we are actually exploring the killer application of quantum computing. And starting from the year 2018, our company started the activities around the quantum computing. With Fujitsu, we have had a joint activity for the simulation with the classic computing, but for quantum computing with Sato-san and Okamoto-san in those days, we had very good discussions, and we were moved by the passions of Fujitsu. Once we started the joint research, the level of technology is very high and advanced at Fujitsu, and our research project is progressing very well. I appreciate that very much. For research project, mainly Mitsubishi Pharmaceutical is we are working with them, and quantum computing is good for the drug discovery and drug development. And that's the main area. And we are going to talk about the details later on. Thank you very much for this opportunity today. Thank you. Thank you for appreciating our passions. All the audience here, I think, are passionate about the quantum computing. Now, the reason why you started the quantum computing research, that's the question I would like to ask. But that's going to be linked with the corporate activities. So maybe I'm going to postpone this question to later stage. So I'd like to move to the next question, which is the prospects of quantum computing research. How do you feel the current results of the research that you are doing of quantum computing? What's the status? What's the progress that you are enjoying? That's the question I would like to ask. Maybe starting from the other ways around. Mr. Koji, please. When it says quantum computing research, is it for the company as a whole, or is it about the collaboration with the Fujitsu? With your like a strong determination, what you feel strongly, please talk about that. Basically speaking, we are trying to have a clear application of quantum computing. That is, we are trying to identify and develop. And when it comes to the quantum computing, actually, the computational power is very high. There's no doubt about that. But for actual application to the industry, how should we use that? It's not yet clear. And we like to identify that first. And after that, with the hardware advancement of quantum computing, in the area that we select, and we are going to have the computation that's a high scale and connected to various areas of the company. And quantum computing is particle science and AI, and also other research. We are doing the research in various cases, and what we are doing with Fujitsu is exploration of material and drug discovery, drug development, specifically stating protein and the drug. The interaction of that is actually evaluated by quantum computing at a high accuracy. That's what we are doing. And what is difficult is the quantum compute actually compute by particles, but the protein research is quite big, so it is very difficult to use quantum computer only to do all the computation. So we are talking with Fujitsu and making the combination of classical computing and quantum computing, and we are trying to identify the interaction in the drug discovery and also protein formation, and that's what we are trying to do. And of course, we use quantum computer for that. And as a one direction, AI and quantum computing to combine them in an effective manner and achieve the application of quantum computing at early stage. That's the direction that we're heading for right now. So you combine AI and other different industries with quantum computing, there must be some challenges. What specific actions are you taking to address that? Well, AI for quantum, in that context, for instance, in terms of quantum computers, coherence impact is there. So there is no computation available for long gate, but by taking advantage of AI, you can shorten the circuit, or using AI, error correction technologies can be applied. Then with the current quantum computers, you can actually do the computation with a longer circuit, and then you can lead this to commercialization. That's what we are working on in terms of research. Thank you. Takeda-san, would you like to say more? You are in the finance industry, so what sort of research are you engaged in, and how much response that you have been able to get? Well, first of all, how I view the quantum computer industry, I find it quite interesting, because from device to middleware to application to algorithm, nobody knows what is going to happen, and all kinds of interactions are happening with everyone involved in the research. So that makes it quite exciting. So based on our computation, we are engaged in this business and finance, and also
Actuarial optimization is also what we are doing. So we cannot produce a device, but from middleware to algorithm, we can deploy our services broadly, and also we can work with customers to proceed with this. And when it comes to collaboration with Fujitsu, because we're in the financial industry, the financial algorithm advancement is the top priority. What characterizes financial industry is that from a long time ago, we are using numbers. And so financial engineering is the tradition that we have. So there is a formalism that has been established. And also accuracy of the product is well known, and what sort of performance we can get has been well researched and thoroughly researched. So in that sense, there's already foundation for classical computation. So in terms of taking advantage of quantum computers, I think comparison is a bit easier. So in a collaboration with the Fujitsu, using simulators and actual unit, you can actually make comparison with quantum computer with the classical computer, and that is quite interesting. But on the other hand, since we have had formalism since a long time ago, in the classical computation, you can actually use approximation and other methods that you can take best advantage of the classical computers. So there's a certain level of performance that we can achieve with classical computers. So whether we can achieve the unknown value in the quantum computer in that sense, because in financial industry you have to have a guarantee of performance, so FCQC. It has to be used. So that has been consistently since we started our research in this company. But having said that, device has been making progress. So early FTQC is what we are working on, and then we are going to FTQC on a full-scale basis. So rather than waiting for the completeness of the actual unit, maybe at the intermediate stage, we hoping that commercialization will be made possible. The algorithm that we can develop that is not known to everyone, and then move to commercialization. And well, we have been going through trial and errors, so we found it actually very difficult. So in terms of model advancement, machine learning or quantum machine learning type of method was used. But there are so many variables in finance industry, and the number of data points is huge. So even with a cutting-edge supercomputer simulation, it is quite hard to reach the difference between the quantum computer and classical computer. But by using the actual unit machine and with the latest cutting-edge version of the model, we're exploring the possible solutions to get working with the Fujitsu. Thank you. Thank you very much for naming our companies. Well, simulator and hardware we are hoping to develop and so that you can use in your business. So in our case, in the quantum computer, there is a quite high hope that we're pinning on. Fault tolerance was mentioned. Once we reach there, then material calculation is where we would like to apply that technology, but in a very strict manner. For example, material molecule and status can be calculated, and we really need to have the characterization or evaluation of the properties of the material. So band gap has to be in prediction to the order of several nanometers. That is the kind of accuracy that we need for our material development. So quantum computer becomes enough, the fault tolerant enough for that kind of use, then we will be able to use that in our business. But on the other hand, if you look at the current status, the quantum computers that are now making buzz, currently So with the risk that we are running currently, to what extent quantum computers are usable? We would like to have that gut feeling as well. So working with Fujitsu, with the current quantum computer, even with some limitations, what sort of calculation is possible for materials? That's what we are trying to find out. But even with that calculation, the quantum science is really accurate in the classical computation because there's a decades of history and very accurate and precise academic field. But in some fields, with the quantum computers with some risks currently, there might be some areas where we can use them. So there is some sort of idea that we've got through the collaboration with Fujitsu, because this is just a feasibility study that we just got this idea that we could use this, and this is not usable in the actual commercial sense. But there is some silver lining at the end of the tunnel. Thank you. Well, listening to what you have said with us, there are things that we can do and things we cannot do yet. And what are the challenges in the researches in the quantum computers? So maybe we're just focused too much on challenges only, but we'd like to ask you to share those with us. So let's start with Mr. Ko. Well, challenges. With the current quantum computers, if you use this for actual problem, calculation or computation resources are not enough. That is the biggest challenge. And furthermore, if you look at the roadmap of the technologies, so the problem that we really want to solve, in order to use quantum computer for these problems, probably will take 10 years in actuality. So you spend 10 years. Whether we can continue with this research in a single company is a separate question. But with those challenges, in order to address those, the early commercialization of quantum computers is really important. The first possible application may not be that large, but you can increase the number of applications gradually to reach 50Ks. And gradual development work is really important to reach there. So in a direction, the current quantum computers, how we can take best advantage of that and find appropriate application for the current ones. And then FTQC has to be moved up as soon as possible. And how you can improve algorithm to enable that. And the third is what I said earlier, using AI. Well, quantum computers are making advancement, but so is AI. So they are both are emerging technologies and making leaps and bounds. But combining both, you can realize quantum computer practical use. So there are still shortage of resources of quantum computers, and it takes time. Those are the challenges, but we can address those issues gradually through that. Thank you, Mr. Ko. So you mentioned FTQC, but Sato-san, we are working on hardware, algorithm, development includes those, and early realization of those is an issue. What are your thoughts? Well, the issues. Well, I thought I was wondering if our hardware is not good, then what we should do. But as Okuno-san said, for FTQC, NISQ, whether we can find something in NISQ is an issue. You shouldn't just dismiss NISQ altogether. And so Joseph and also we are doing air mitigation and suppression, working with Delft University. But AI technologies are making progress on a day-to-day basis. FTQC is something that we are focusing on, but we are also looking at something else as well. As for FTQC, hardware has to be improved. That is a must. I think everyone agrees that. And in terms of hardware, it's not just a technology, but you have to reduce cost. Maybe that's a sense of technology. But I have been saying that no single company can do that, but we have to work with manufacturers as well as software developers. And as Mr. Ko said, on the algorithm side, you have to reduce the resources required for architecture. So you have to do both. So we would like to work together.
Thank you. We were able to understand the challenges. Thank you. I would like to move on to the next question. The expectation to quantum community. That's what I'd like to ask. There are many audience from various fields, also from people who are in charge of the actual application. I would like to ask, what is your expectation to quantum community? Okay, as Mr. Sato mentioned earlier, hardware is not yet developed fully, and quantum computer research is still theoretical, and actual implementation to the reality needs further research. And achievement of actual quantum computer is a very high hurdle. It's a big mountain, and research is a high hurdle, and it's a struggle. And when we climb the mountain, we sometimes see valley, and we have hurdles and obstacles. And we should not give up at one obstacle. If the company situation allows us to do so, we should take a long-term perspective and a tenacious approach. And one by one, we should overcome the obstacles, and it's important to do the research considering the application. And it's not that that's something that we can get the application or realization in short time, but I think we should take a steady but a long-term approach and perspective. Thank you. And expectation to community. And we are kind of running out of time, so I would like to move on to the next question. Next one is how companies can take steps toward quantum computing research. In order to start that journey, I think we have to take a long-term perspective. How companies can actually start to take steps. I think that can be a hard question for companies. And the panelists who are here have already started that journey. How did you start the journey? That's the question. Mr. Takeda, can you please answer that question? Okay. Well, because it is the activity of company, we cannot start by individual. We have to get the permission, understanding by boss. And we need to get the buy-in from higher ranked people. Then we can start the research. And in our case, the working level people actually advocated about this, and the bosses and executives agreed on that. They had quite a generous way of considering new technology. And what's important for the working level people to take a bottom-up approach, we have to use easy language. We have to make it simple to understand. Otherwise, people will not understand and will not buy in. And continuity is very important. And also, in order to continue the activity, we should not exaggerate. Of course, sometimes things do not work well, but we should continue and then start to see a good results after a long time. So if you do some activities, then they cannot get the results right away. We should not give up. Quantum, I think, is disruptive technology. I think that will change the world. And talk about that with passion is, I think, most important. Thank you. Bottom-up approach and appeal with passion. Do not exaggerate. Thank you. And I would like to ask the same question to Coach-san. Well, why people cannot start the journey? I actually had a discussion with other companies, and my feeling is that the reason why they cannot start the journey is partly because quantum computing is highly potential, but the people do not know when it can be achieved. And we do not know whether it's going to become usable. And they think they can actually start once the technology becomes feasible. That is a mindset I observed, and we should get rid of that mindset rather than giving up that because of the risk. We should take risk. Risk is equal to challenge. And the companies should take risk. I think it's important for companies to do so. And quantum computing, if you don't take the risk now, in 5 years, when quantum computers are really effective and usable, what's going to happen? If I imagine that hardware will be short, and companies who do not start right now, they may not be able to start in 5 years. They will be left behind, and they will be losing the competitiveness against the companies who did that. For example, if you spend like 100 million yen per year as research investment, then you can get the leadership position in this research. If you have that kind of mindset, you can start the journey, you can step forward. Our management team has that a good mindset. And top management, executives, consider the risk of not doing so. And we should take risk by doing the research. That's the reason why we have started that journey. Thank you. How about you at Fujifilm? In your company also, relatively speaking, the development also executives have good understanding. That's the reason why we were able to start the journey and the progress with the research. This has been mentioned already. We should not lie or we should not exaggerate. For example, there are some catchy headlines of newspaper. We should not just talk about those headlines. It is very important to explain the realistic situation. And that can be the relationship between risk and expectation. Once it is developed, we can become forefront or top runner. We can be advanced against other companies. I try to explain that way. And understanding and buying from executive is very important, maybe the most important, to step forward. Sometimes executives have a conservative mindset, and it's not really too conservative because their executives, they also, of course, consider the risk. It's valid for them to do so. But what's the risk tolerance? That level is different depending upon what company you are. Thank you. Now, moving on to the next topic. for the companies who have started that journey already. And maybe this is repetitious from a previous topic. When companies utilize quantum computing, what are the challenges? Rather than the technical challenge, and companies do the quantum computing researches, the challenges of resources, or what kind of challenges are there, and how are you trying to tackle on those challenges in the companies who actually start this journey? What kind of challenges they are going to confront, and how do you suggest to overcome that? Who should start? Maybe Coach-san, can you please start? The challenge of utilizing quantum computer. Quantum computer, there are various methods or formats like superconducting and also photonic ion trap and also neutral atom for. There are other potential formats of quantum computing. And what do you want to use? That is a very hard question to answer. To be honest, if we can try out various ones and select the optimal one, it's very important to do so, but the resources are limited in the research, so it's very difficult to try out everything. So there are various kinds of quantum computing, how to select and apply that to our own use cases, how much resources we are going to spend. I think that is one big challenge. And also, quantum computer research is progressing very rapidly. Last week, we thought this is impossible, but in 1 month, we start to see a paper to talk about that, and it becomes possible. These kind of technologies, it is very difficult to catch up with the state-of-the-art technology all the time. So how can we do the state-of-the-art, the latest technology research? That's one challenge. And for this kind of research, we try to use partnership. We try to work with the various companies, not doing everything on our own. It's not possible to do so. So we try to work with the companies who are advanced, and we can, I think, solve those challenges.
Thank you very much. Now, with regard to partnerships, I'd like to ask a question. Can you be more specific? In what format are you engaged in partnership? With regard to partnerships, one way is using ecosystem. For example, Fujitsu is promoting an ecosystem, and you can join that as a company. And then together with Fujitsu and other related academic organizations, through partnerships, we can promote joint research. That's one thing. And then another is national projects is where you can also participate. And then industry, academia, and government partnership can be promoted. So we're talking about open innovation, and with an ecosystem, participating in one of the national projects is important. And if we are getting closer to commercialization of quantum computers, you can actually have a bilateral relationship with hardware, software vendors. But so in the future, that might be a possibility. So you talked about partnership formats, including industry, academia, government collaboration. Now, the same question to Takeda-san. So you're talking about the current status, right? Well, so what you think is a question or issue in the future or currently. So I would like to share with you the issues, including those in the future. So currently, as a company, I think the talent is the biggest issue. The quantum computer algorithm, I think many of you in the audience has the experience to play with that, and it is quite different from ordinary algorithm, and you have to be specialized and trained. So it's not the case that only 1 month or 2 months of training would be enough. So, and also if you have to tune that to apply to your own specific needs, then you need more time. So you have to gather the talent that is good enough. So in our company, people with physics background is numerous, so there were less hurdles. But they have to continue to be engaged in the development and research. Otherwise, there won't be accumulation of expertise in a fresh and cutting-edge manner. Now, what we were allowed to use from Fujitsu, the actual simulator usage environment is really important. And Fujitsu is well known in Japan. So you have to secure some sort of environment where you can use the machine. And in the future, there are a lot of things that we are discussing inside the company. So actual usage of quantum computers, where are you going to locate them physically? And you have to make sure that they have to be operational 24/7, maintenance and data location, storage, and also expense that is required. Those are all issues in the future. Thank you. Well, I'd like to ask a question to Sato-san. Hardware resources were mentioned earlier. So what is your thought on that? So in the future, of course, that will be in shortage. So if quantum computers are commercialized, we would be able to provide enough resources. But of course, you have to hit the right balance with the cost. For example, Fugaku there's only 1 unit of Fugaku in Japan. So how you can jointly use or share the usage of that particular machine is a question. And there's a balance between performance and cost. That would be the key. So that would be also determined by or influenced by the progress in the development in the future. Now, Okuno-san, what do you think is the issue? Well, if the quantum computer becomes fault tolerant in the real sense of the word, suppose that the quantum computer can do all the job. Not all the computers will be replaced by quantum computers. For example, encryption or decryption of encoding, or it's just a calculation of one single material. Like a specialized use of computers is more of a usage for quantum computers, in my view. So we can actually use the cloud space or time share of the memory for the calculation space. And if it is not the fault-tolerant quantum computers, but if we want to use the NISQ age quantum computers, then what would be the killer application? That is something that we are exploring. We believe that would be material calculation, but that is the difficult thing to find out what would be the killer application for a NISQ computer, quantum computer. So there's no NISQ era quantum computer killer application that has emerged. Why not? Well, I am in the material computation field, but when you look at the classical computers, and the computer technologies do have several decades of history, and it's very precise and accurate, and there are a lot of different methods available. So compared to them, in terms of NISQ quantum computers, can they beat classical ones? So in the material computation in the classical computers, there is a history and a track record. So if you can beat that is a question. Thank you. Well, we are running out of time. So let us move to the next topic. So the prospect for quantum computer research is, so you are engaged in the current research activities, but beyond that, by using quantum computers, what sort of world would you like to create? If you can share your prospect or thoughts with us. Mr. Cole, please. Thank you. Well, as we look into the future, the quantum computers should be able to be applied in all parts of supply chain. We're just talking about small molecule calculation for exploring materials and screening the compounds. These are the immediate objective right now, but in the future, for example, in the company business model, if you do the optimization, what would be the new solution? That sort of question of exploring new solutions is where we would like to apply the technology. Or in the future, in terms of B2B business, what sort of optimization would be necessary? You can use the technology to answer that question. So in my mind, the application of quantum computers, if we can do this well, in the future, you can combine the quantum computers with classical computers or replace classical computers to see the applications and solutions that are not known now, hopefully. But basically, classical computers, with regard to the computation, there are many problems that classical computers cannot solve. So that's where we'd like to take advantage of quantum computers, but that will be further down the road in the future. Thank you. Takeda-san? Yes. Well, there are three perspectives. My company's policy and my personal policies are mixed together. First of all, the current financial algorithm can become more advanced with quantum computers, but algorithm development takes time. But you can speed up that, or you can expand the expression scope so that you can come up with better model to beat competitors and increase profitability, and then provide better products at a faster pace to the customers. And the second one, FTQC and NISC, the performance is not good. That's what was mentioned, and most of the algorithm vendors have that sort, but I think this is a good opportunity. There are people who are taking advantage of FTQC, but if you find algorithm that is good enough in NISC, then that would be the sole winner. I think this is the idea that financial industry personnel would like, but you can actually make low-profile efforts to find some application that is fit for NISC quantum computers. And then there will be more advancement that you would see. The third is the quantum computer prospect. Well, quantum is a disruptive innovation, but if you use the quantum computers to the current products, then you are just using the computer, the current computer, for the question that or problem that the current computers can solve. So it's just a linear issue. But in the real sense of the word, when you think of social innovation, the quantum computers with less noise can be tried. And then if there is a exponential application algorithm that is found, then you can actually deploy the application that has never been seen in the world. And I would like to experience that, and I would like to make some contribution in a small manner to that, if that happens. Well, I am just a narrow scope of material research, but in the material research, a Schrödinger equation is being solved, and I use approximation method, but as was mentioned, if you solve that more precisely, and the actual measurement of material properties, and if you can use that to the preciseness of several decimal points, or you can project the precise material, if those are made possible, then that would make my dreams come true. And also, in my own areas of research, that is the ideal status of quantum computer. Thank you. Well, I'm sorry, my hands are full, but time is up, or we have run over the scheduled time. Well, it's unfortunate, but we have to wrap up and close this session. Today, in this venue, the IT media, Mr. Kisa, is here with us. So there are things that we were not able to discuss today, and the articles, there are journalists that can discuss what we were not able to discuss today will be reported. So I hope that you can stay tuned. Thank you.